Most businesses think quality problems appear out of nowhere, but the truth is, most of them give off warning signs long before they explode. The issue isn't that the data doesn't exist, it's that no one's paying attention to it. That's where control charts come in. They turn your process data into a living heartbeat, showing you when things are healthy and when they're starting to drift. And if you're pursuing your Six Sigma certification, learning how to use control charts will change the way you see variation forever. In plain English, a control chart is a simple visual tool that helps you track process performance over time. Imagine plotting a line of daily results, maybe the time it takes to fill a customer order, or the weight of a packaged product. The chart shows not just the data points, but also three important reference lines: the average, the center line, and the upper and lower control limits. Those limits define the natural boundaries of variation in your process. If your data stays within them, your process is in control. When a point jumps outside the limits or starts showing strange patterns, that's your signal. Something's changing. You can think of a control chart like a heart monitor for your process. It doesn't just tell you when you've had a heart attack. It helps you see the early signs of stress so you can intervene before disaster strikes. That's what makes it such a cornerstone of Six Sigma work. It allows you to separate normal noise from real signals that require action. Let's bring this to life with a simple story. Imagine a bakery that prides itself on consistency. They bake hundreds of loaves of bread each morning, and customers love that every loaf is the same soft, golden brown perfection. But recently, complaints have started trickling in. Some loaves are too dark, some too light. The owner decides to collect data on oven temperature and bake time for every batch. Each day, she records the baking temperature and plots it on a control chart. Over the first week, most of the temperatures cluster around 350 degrees Fahrenheit, give or take a few. The control limits, calculated from the data, sit at 345 on the low end and 355 on the high end. For a while, everything looks good. Then one day, a few data points start edging toward 356, 357, even though they haven't crossed the upper limit yet. Now here's where control charts shine. Those creeping points are an early warning, what Six Sigma practitioners call a non-random pattern. The owner checks the ovens and discovers one of the heating elements is wearing out. It hasn't failed yet, but it's starting to lose precision. She replaces it before any real defects occur. The result? Consistent bread, happy customers, and zero waste. That's the magic of control charts. They give you a way to see the invisible drift before it turns into a crisis. And that's why they're a fundamental skill in Six Sigma certification training. Control charts come in different flavors depending on the type of data you're working with. If you're tracking continuous measurements like time, weight, or temperature, you might use an X-bar and R chart, which shows both the average and range of sample values. If you're counting defects or errors, you'd use a P chart or C chart instead. But the principle stays the same. Monitor performance over time, compare it to the limits, and watch for signs of special cause variation. Special cause variation is the kind of change that comes from something unusual: a broken tool, a new supplier, a distracted employee. Common cause variation, on the other hand, is the natural, expected fluctuation in any stable process. The real challenge in quality management is knowing which kind of variation you're dealing with. Control charts help you make that distinction visually and statistically. If you're new to Six Sigma, this idea might seem technical, but it's actually very practical. Think of it this way: every process varies, even when nothing's wrong. The trick is knowing when that variation means trouble. Without control charts, teams often overreact to normal ups and downs. They tweak settings, retrain workers, or chase ghosts that don't exist. Ironically, all that tinkering introduces more variation. With a control chart, you can see when to act and when to leave things alone. Let's take another example, this time from a service business. Picture a small insurance call center that tracks how long it takes to handle customer calls. Management wants calls to average around 6 minutes. Without a control chart, they only look at the daily average. Some days it's 5.8 minutes. Some days it's 6.2, and they start panicking when it hits 6.5. They make quick changes, shuffle agents, add scripts, but nothing seems to help. Then a Six Sigma consultant introduces a control chart. They plot the daily averages for a month and find the upper and lower control limits are actually 5.4 and 6.6 minutes. In other words, the bad days weren't bad at all. They were within normal variation. The real issue shows up 2 weeks later, when the average jumps to 7.2 minutes and stays there for several days. That's a true signal. They dig deeper and find a new billing system went live that week, slowing down every call. Fixing that issue returns the process to normal. Suddenly, everyone's calmer. Decisions are based on data, and improvements are targeted instead of random. That's the difference between reacting and understanding. Control charts don't just help you see data. They teach you patience and discipline. They build confidence that your process is stable when it should be and alert you when it's not. Of course, there are pitfalls to watch out for. One of the biggest is using control limits incorrectly. Some people confuse them with specification limits, the targets set by customers or engineering requirements. They're not the same thing. Specification limits show what the customer wants. Control limits show what your process is naturally capable of. Mixing them up leads to false conclusions, like thinking your process is fine because it meets specs, even though it's actually unstable. Another pitfall is ignoring data patterns that don't cross the limits, but still signal trouble. For example, if you see 7 points in a row trending upward or downward, that's a red flag. It means something's shifting, even though the data hasn't technically gone out of control yet. Experienced Six Sigma professionals know that patterns matter as much as points. There's also the danger of collecting too little data. A control chart built from 5 data points isn't reliable. It can't tell you much about long-term behavior. You need enough data to understand natural variation before setting control limits. Otherwise, you'll be chasing random noise. And finally, there's the human side of the equation. Control charts only work if people trust them. If leadership still demands knee-jerk reactions to every small change, the chart becomes a decoration instead of a decision tool. The real power of control charts comes from a culture that values data-driven thinking over hunches and panic. When used correctly, though, control charts become one of the most empowering tools in your Six Sigma toolbox. They shift your focus from firefighting to foresight. You start seeing processes not as static tasks, but as living systems with rhythms and signals. You learn that variation isn't the enemy, it's information. And once you can read that information, you can predict and prevent problems before they happen. For anyone pursuing Six Sigma certification, mastering control charts is a rite of passage. It's where theory meets reality. It's the moment you move from reacting to managing. Whether you're on a factory floor, in a hospital, or behind a computer, control charts teach you to see beyond the averages, to read the story your data is telling in real time. Here's the simple takeaway. Without control charts, you're flying blind, reacting to every bump and dip. With them, you're flying with instruments. You can see the weather ahead, adjust course early, and arrive safely every time. So the next time you collect data, don't just average it, chart it. Watch it breathe. Listen to the rhythm of your process. Because once you understand that rhythm, you'll never see variation or improvement the same way again. That's the insight that separates someone who has a Six Sigma certification from someone who lives its principles every day.